welcome to Tennessee's At Home Learning Series. This is for all our fourth graders out there, even though anyone is welcome to tune in. This is the 8th lesson in our series. My name is Miss Pereira. I'm a fourth grade teacher at Vena Stewart Elementary here in Gallatin, Tennessee. Thank you for inviting me into your home today and welcome to my virtual classroom. Today we're going to think about subtracting fractions. A fraction is a number that names equal parts of a whole. We will also think about how to model our thinking with pictures and number lines. So let's warm up with just thinking about this question. One-tenth more than 5/10 is what? What do you think that could be? And we can model that with a number line. So I'm going to draw a number line. How many equal pieces do you think I need in my number line? 10, correct, because the denominator tells us how many equal pieces are in the whole. So I'm only talking about one whole here. So I'm good with my number line being from 0 to 1. And then I need to break it up into 10 equal pieces. So I'm going to break it up into fifths, with my fifth tick mark being that whole piece. And then I'm going to go back and split those in half, so that I should have 10 equal pieces. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. So I can go through and label my tick marks. Remember, as we go up on the number line, our numbers get bigger because we have everything up to that point. 9/10 and 1 whole, or 10/10, because if we've got all the pieces, we've got the whole thing. So 1/10 more than 5/10. So let's find 5/10 on the number line. Very good. And then we need to know what is 1/10 more. So are we going to go up on our number line or down? Very good. More, we're getting bigger. So we're going to go up on our number line 1/10. So we can see that 6/10 is 1 more than 5/10. So let's look at another example. This time, what is 1/10 less than 5/10? Again, we could model that with a number line. Just like you told me in the first one, we need to break it up into 10 equal pieces. We're only talking about one whole. So we're good with our number line only going from 0 to 1. Before I start labeling, I'm going to make sure that I do in fact have 10 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I can go through and label my tick marks. One whole, or 10/10. So this time I'm going to find 5/10 on the number line, but I'm looking to see what number is 1/10 less than 5/10. So this time I'm going to go down on my number line because I'm getting smaller. I'm taking away 1/10. So we can see that 4/10 is 1/10 less than 5/10. A great little warm up to get us started today. Now, let's look at a word problem to put this knowledge into action. Read this word problem with me. Alberto's water bottle has 5/6 of a liter of water in it. He drinks 4/6 of a liter. What fraction of a liter of water is left in the bottle? So I always like to do that second reread thinking about what do I know? What do I need to know? So it tells me how much water was in his bottle to begin with, 5/6 of a liter. Then it tells me how much of that water he drank. He drank 4/6 of a liter. And what we're trying to figure out is what fraction of a liter of water is left in the bottle. So a liter is a metric unit of measurement used to measure liquid volume. So let's pull out our important information. So we know that he started with 5/6 of a liter. We know that he drank 4/6 of a liter. And so we're trying to figure out how much water does he have left. And we can draw a model to help us think about that. Think about a water bottle. Normally stands up kind of tall. So this time, let's draw a tall, skinny rectangle to represent Alberto's water bottle. So there's his water bottle. How many equal parts do we need to divide our model up into? Correct, 6 equal parts, because it told us he had 5/6 of a liter. So we know that he's already thinking about his water in terms of 6 equal parts in the whole. I like to start with dividing mine into thirds and then going back and split those thirds in half. It helps me make sure my pieces are just a little bit more equal. So what fraction would name one of these pieces? 1/6, very good. So each one of these pieces represents 1/6 of a liter. And we know that he started with 5/6 of a liter of water. So we can shade our model to represent the water that he started with. 2/6, 3/6, 4/6, 5/6. So his water bottle wasn't all the way full to begin with. It was only 5/6 full. And then he drank some of the water. So what could we do on our model to show the amount that he drank? Right, we can just X it out. He drank 4/6, meaning he drank 4 of those 1/6 pieces. And so how much water did he have left? Correct, 1/6 of a liter. And we can see that very clearly in our model. He had 1/6 liter of water left. So if we go back and we look at all of these fractions, we notice that they all have a denominator of 6 because we were dealing with one whole water bottle being split into 6 equal parts. Let's look at this numerator 5. Where in our drawing do we see the 5 represented? Very good. The 5/1/6 that are shaded in red, representing the amount of water he started with. The 4, the numerator 4 here, where do we see it represented in our drawing? Yeah, the 4 pieces that have X's over them because he drank 4 of those 1/6 pieces. And then this numerator 1, where do we see it represented in our drawing? Correct. This last piece that doesn't have an X over it is the 1/6 piece that he had left after he drank some water. We could also model this with a number line. So I'm going to kind of put those side by side so that we can look at both of those models to solve the same problem. So again, we already know how much water he started with, how much he drank. So we need to draw a number line. And just like we split our water bottle up into 6 equal parts, we need to split our number line up into 6 equal parts. We're only dealing with one whole, so I'm good with my number line just going from 0 to 1 because I'm only looking at one whole piece, and I need to split it into 6. I like to split into thirds and then go back and split those in half. And then before I label my tick marks, I'm going to make sure that I do in fact have 6 pieces. 1, 2, 3, 4, 5, 6. So now I can go through and label my tick marks. As I go up on a number line, my numbers get bigger as I get closer and closer to that one hole. Okay, so how much water was in his bottle to start with? Correct, that 5/6 liter. So we're going to find that point on our number line. This was his starting point. Then he drank some of the water. So we're going to go up on our number line. Is he going to have more water in his bottle, or are we going to go down? Is he going to have less? Right, we're going to go down. He drank 4/6. So we need to go down 4/1/6. So 1/6, 2/6, 3/6, 4/6. And we can see that he is left with 1/6 liter in his bottle. So let's review what we learned. We can see that both models deal with one whole split into 6 equal parts. We can easily see the 5/6 represented on our number line and the 5/6 shaded in our drawing. We marked out to represent losing the 4/6 here. We went backwards on our number line to represent losing the 4/6 here. And then we can see that there's 1/6 left in each model. Last but not least, we could write an equation to show what was happening here. We started with 5/6. We took 4/6 away, and we were left with 1/6. We could also write that in unit form. We had 5/6. We took away 4/6. We were left with 1/6. All right, let's do some more practice together. Let's do 3 more practice problems together. By the time we get to the third one, you should be able to do it on your own, and then we'll check together. I'm going to divide my board into 3 pieces. I'm going to go horizontal so that I have plenty of room for my number line. For you all at home, make sure you've got plenty of paper to work these problems out. Okay, the first one we're going to look at has to do with mowing the lawn. I'm sure you all probably seen a lot of people mowing their lawn around your house. It's getting that time of the year. So Carmen has 8/10 of the lawn left to mow. She mows 5/10 of the lawn. Now, what fraction of the lawn is left to mow? So let's think about that for a minute. Let's go through what do we know? What do we need to know? We know that she has 8/10 left to mow. So she still needs to mow 8/10 of her yard. Well, she went ahead and she mowed 5/10 of the 8/10 that she had left. So what fraction of the lawn is left to mow? So let's draw a model to help us with working that out and finding the solution. Let's pull out what we know. We know that she has 8/10 left to mow. We know that she mowed 5/10. So we're looking what's left now. So we really explored that number line a lot. So let's try that number line model to help us solve this one. So on your paper, draw yourself a number line. We're only dealing with 1 yard, so we only need our number line to go from 0 to 1. How many equal pieces do we need in our number line? 10, very good, because she has broken her yard up into 10th sections. So again, I'm going to start with dividing my number line up into fifths. And then I'm going to go back and split those in half so that I should have 10 equal pieces. Let's check it and see. You check yours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can go through and label my tick marks. One whole yard or 10 tenths. Okay, so we know that she had 8 tenths left to mow. So let's mark 8 tenths on our number line. And then of the 8 tenths that she still needed to mow, she went back and mowed 5 of those tenths. So we can take 5 of those tenths away from the original 8 tenths that she still needed to mow. So if we're taking away, we're getting smaller. So we're going to go down on our number line. So 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths. So when we take away those 5 tenths, we stop at 3 tenths, showing that she still needed to mow 3 tenths of her yard. Think in your mind, what equation could we write that would match our drawing? We always start with what she started with. She had 8 tenths left to mow. Then she went back and mowed 5 tenths of that. So she only has 3 tenths of her yard left that she still needs to mow. Okay, let's look at another one. This one I'm going to give a little bit less guidance, but I'm still here to help if you need me. This one has to deal with a carton of eggs. So before we get started, just close your eyes and think about a carton of eggs. Mrs. Kirk has 3/4 of a carton of eggs. She uses some for baking and has 2/4 of the carton left. What fraction of the carton does she use? So let's think about that for a minute. What do we know? What do we need to know? So let's go through and look. We know that she started with 3/4 of a carton. We know that she used some for baking. We don't really know how much. But that she has 2/4 of the carton left. What fraction of the carton does she use? So that's some. That's what we're trying to figure out. How much did she use for the baking? So let's pull out our important information. So we know that she had 3/4 of a carton. She used some, we don't know yet, for baking. And we know that after she used some for baking, she had 2/4 left. So we're trying to figure out how much did she use for baking. So again, we can draw a number line to help us think about this. So let's draw a number line to represent her carton of eggs. Again, we're only looking at one carton. So we're okay if our number line just goes from 0 to 1 because we're looking at one carton of eggs. How many equal parts do we need to divide this number line up into? Correct, 4. So I like to split mine in half and then split those pieces in half, and we get 4, 1, 2, 3, 4 sections. Each of those sections representing 1/4 of the carton. As we move on up, we've got 2/4 of the carton, 3/4 of the carton, or one whole carton, 4/4. So we know she started out with 3/4. So we can find 3/4 on our number line. And we know that she had 2/4 left when she was finished baking. So if we take 2/4 away, 1/4, 2/4, we can see that there's 1/4 left, which means that she must have used 1/4 of the carton of eggs for her baking. What equation could we write that would model this thinking? Write it on your paper and then we'll check. Correct. 3/4. Take away the 2/4 that she had left means that she must have used 1/4 for her baking. One more problem that I'm going to let you do on your own, and then we will check it together. This one has to do with reading a book. Andrew reads 4/8 of a book. How much of the book does he have left to read? I'm going to give you a minute and a half to work this problem, and then we'll check it together. So if he read 4/8 of the book, what did he split the whole book into? Correct, eighths. So he split the book up into 8 equal sections, and so far he's read 4/8 of it. Great job. So how much of the book does he have left to read? Correct, 4/8. So if we model that on a number line, we know we need to split. We're only dealing with one whole book. So again, 0 to 1 on our number line is fine. We need to split it into eighths because he told us he read 4/8 of the book. 1, 2, 3, 4, 5, 6, 7, 8. And this one was a little bit tricky because it didn't have a lot of information. So we know if he started out with the whole book, he started out with one whole book. That's kind of the piece of information they left out that you just had to get from what they told you. And then he read 4/8 of it. So 1/8, 2/8, 3/8, 4/8. So he finished 4/8 of it. We can see that he still had 4/8 left to read. An equation that we could write that would match that. He started out with 8/8 or one whole book. He got rid of or read 4/8 of it. So he has 4/8 left that he still needs to read. Great work. I'm now going to show you some independent practice that you can do on your own. You can pause the screen, take a picture of the screen, or you can go online to www.tennessee.gov/education to find this work sample to give you some additional practice. 1 through 4 are based off of this first word problem. And then you have another word problem for 5 and just some simple solve for the answer in number 6. You all worked very hard today. Thank you again for inviting me into your home. I can tell that you all are learning and growing with every lesson. Keep up the good work.
What's up, all you crazy Tennesseans? It's me, Coach Wood again. Let's get up, get off your couch, let's get moving, all right? I got toilet paper in my hand. If you want to grab some toilet paper, go ahead. Join in on the fun. Let's just run in place for a minute, all right? We're just running through the neighborhood. What's up, man? Whoa, keep your distance. Good to see you. What's up? Woo! Go a little faster. Oh, I'm going. I'm running in my garage with toilet paper in my hand. Remember, it's important to get off that couch. Video games are fun, TV's fun, but you got to get up and move. Look it, we're moving with toilet paper. You can do it too. Keep moving, keep moving. Shake it out. Shake it off, shake it off. Hashtag Taylor Swift, here we go. Whew. Let's do some jumping jacks. Remember, pencil, X, pencil, X. Super simple. Let's get 10 in there, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo. Here we go. Last thing, USA, baby. USA, USA. Here we go. Last thing, we're gonna do some of my favorite. If you've watched my videos on YouTube, these are called star jumps. All right, touch the ground, jump up, star. 1, 2, 3, 4. Here we go. 5 more. 1, 2, 3, 4. Come on. 5. Woo. Shake it off. Whew. See, look at that. We haven't been working out for even 2 minutes. I'm already breathing hard. I know you're breathing hard. You guys are doing great. Keep it up at home. Keep up all the awesome work. And follow me at youtube.com/c/coachwood. Check out my other videos. Peace.